Okay, now we're going to be working with equations with two radical terms. Now, the algebra in this one is going to be rather complicated, but still workable. Now, for the first equation, we had the square root of 2x plus 7 plus the square root of x minus 5 is equal to 7. And if we isolate one of the radical terms, and we will isolate the square root of 2x plus 7, so if I take away the square root of x minus 5, we're going to have, in the formation, we will have the square root of 2x plus 7 is equal to 7 minus the square root of x minus 5. And to free up the radical, at least on the left-hand side, or free up 2x plus 7 from the radical, okay, with square roots, I'm going to square both sides. And for what we have in this particular case, for the square root of 2x plus 7 squared, okay, so you have 2x plus 7. And we have with the square of 7 minus the square root of x minus 5. So you have 2x plus 7. And to the right, you have 7 times 7 is 49. And we have minus 7 square root of x minus 5 minus another 7 square root of x minus 5. So we have negative 14 times the square root of x minus 5. Negative times negative is a positive. And we have x minus 5. And here we have 2x plus 7. And 49 minus 5, we have at 44. We have minus 14 times the square root of x minus 5. And we have plus x. Now, in this go-round, we have one radical term remaining. And we're going to isolate this term. So we're going to move the 44 and the x over by subtracting on both sides. So we have, this time around, we have 2x minus x becomes x. 7 minus 44 is negative 37. And we have is equal to negative 14 times the square root of x minus 5. And taking what we have and squaring. So we have the square of x minus 37. And we have is equal to the square of negative 14 times the square root of x minus 5. And squaring out x minus 37, this would be x minus 37 times itself. And so we would have x squared minus 74x. And negative 37 times itself, this will come out to 1369. Rather a large number. And to the right, if I square out negative 14, I have 196. Square root of x minus 5 squared. This will leave us with x minus 5. And we have for the distributing, okay, we're going to have a quadratic equation. And right now we have x squared minus 74x plus 1369. And we have is equal to 196x minus 980. And as we look at combining variable terms and constants and setting up the quadratic equation in its standard form. Okay, so I'm going to take away 196x and also undo the subtraction by 980. And so we're going to have in the rewrite, okay, so you have x squared minus 270x, and we have plus, in this particular case, okay, so that is going to be 2349. Okay. And we have is equal to 0. And what is going to happen in this particular case, all right, is that we have upon factoring. Now we have some large numbers to work with. Okay, now from x squared we have x and x, and then we have, in the case of the factors, and we have a -9, and also we have a -261. And just taking what we have now, upon utilizing the zero product property, we have x minus 9 is equal to 0, so we have an attempted solution with x is equal to 9. And as for x minus 261 equal to 0, we have an attempted solution with x equal to 261. And if I go back, okay, so we have a 9. 2 times 9 is 18, plus 7 is going to be 25. And the square root of 25 is 5. 9 minus 5 is 4. Square root of 4 is 2. 5 plus 2 is 7. Now, in the case of what we have with 261, okay, so you have 261 minus 5, that's 256. And so that's going to be 16. And for 261, okay, you have 2 times 261 plus 7. And that's going to be a large number, and large number plus 16 is not going to come out to 7. So 261 is not going to check out. So there's going to be only one solution in the case of x, and we have that x is equal to 9. Now, in another case, okay, say we have the square root of x plus 17 minus the square root of x plus 1 is equal to 2. And if I isolate, let's say, the square root of x plus 17, and I add the square root of x plus 1, and so we have in this one, okay, so we have the square root of x plus 17, and we have is equal to 2 plus, okay, the square root of x plus 1. And we have squaring both sides. And we have here, so we have x plus 17. And then squaring out 2 plus the square root of x plus 1, you have 2 plus the square root of x plus 1 times itself. So we have x plus 17, and we have is equal to 4. You got 2 times the square root of x plus 1 plus another 2 times the square root of x plus 1. Again, we have plus x plus 1. And we have upon combining, okay, so we're going to have, in this one, so we have 5 plus 4 times, okay, the square root of x plus 1. And we have plus x, and for what is going to occur here, if we combine like terms, x is going to go out, and we have, in the case of moving the 5 over, so as to isolate the radical. Okay, so we have 17 minus 5 is 12, and we have is equal to 4 times the square root of x plus 1. And you can go ahead and square both sides, but since 4 is completely divisible into 12, we can go ahead and divide both sides by 4. And so we're going to have, for the square root of x plus 1, that is equal to 3. And then looking at squaring both sides, so you have 3 squared, and we have is equal to the square root of x plus 1 quantity squared. And we have 9 is equal to x plus 1. And we have that x is equal to 8. And we can go back and check. Okay, so we have 8 plus 17 is 25. Square root of 5 is 5. 8 plus 1 is 9. Square root of 9 is 3. 5 minus 3 is 2. And so we have consistency. So we have x equals 8 as the solution.